New York City as we know it today has been shaped by the subway. More than any other public works program or municipal plan, it has been singularly responsible for the city's growth and global competitiveness for 100 years. Its profound impact, particularly in the outer boroughs, surpasses such widely acclaimed projects such as the Brooklyn Bridge and the Robert Moses Highway Network.
In 1898, the unification of New York City was accomplished. Old methods of transportation were inadequate, and the need for a subway system was clearly evident. The first contract for this exciting new project was awarded to John B. McDonald. However, the task of running the subway would be a monumental undertaking, and so the Interborough Rapid Transit Company, also known as the IRT, was incorporated in 1902 as an operating company to run the subway. The first New York City subway triumphantly opened on October 27, 1904. It was an event like no other that New Yorkers had ever seen. Passenger congestion was so acute that one newspaper reporter wrote, "It was immediately evident that the cars did not have enough doors, the trains did not have enough cars, the subways did not have enough trains, and the city did not have enough subways." But for the average New Yorker, the new subway system was a success, and it put New York City on the map for having completed a great public work.
But without subway cars, there would be no subway, in which millions of New Yorkers and visitors to the city rely on day and night to get them to and from their destinations. The subway backers' motto, City Hall to Harlem in 15 minutes, would become a standard that these subway cars made of wood and eventually of steel would live up to for years to come.
Prior to the opening of the subway, a great deal of thought went into designing the new cars. The main concern of designers and engineers was safety. Using their expertise, they worked tirelessly to create the safest cars possible, and by 1904, the rolling stock arrived, and the new subway opened.
Well, the very first cars ordered were called composite cars because they were a composite of wood and steel, steel frames, steel underframes. But they had wooden sides and with copper sheathing over the lower part. And they were designed to preclude the operation of railroad freight cars through the tunnels. They were 51 feet long and 9 feet wide, roughly. The tunnels were designed to follow the layout of the street, the routes of the street, so as a result there were very sharp turns. And the original, August Belmont, who originated the subway, did this deliberately because he was afraid that the so-called robber barons of the railroads would see this wonderful way of getting freight delivered throughout the city, and they'd try to move into the subway system.
Two composite samples, the August Belmont and the John B. McDonald, named after the financier and the builder of the subways respectively, arrived at the IRT in 1902. Although the composite cars had a frame reinforced with wooden side timbers, the lower half of the car had a simulated wood design etched into the metal. This protected the car in the event of fire. This also gave rise to the appellation copper sides, used by the men of the IRT to differentiate them from the steel cars that arrived later. When the cars arrived from the builders, all of the electrical parts and other equipment were installed at three railway shops, 98th Street, 129th Street, and the main yard and shop at 147th Street and Lenox Avenue. The cars were tested extensively on the 2nd and 3rd Avenue elevated lines. The composites would prove themselves to be dependable cars. But in 1903, the first steel passenger car arrived. The first all-steel passenger car in the world was built by the Altoona shops of the Pennsylvania Railroad for the IRT. Car number 3342 was a one-of-a-kind, designed by George Gibbs, the chief engineer of the Pennsylvania Railroad.
They were the Gibbs cars from the early 1900s until 1957. It's a long time for a subway car. And these cars were very strong, and they could do just about anything. Unfortunately, I didn't get to operate them, but I did ride them. And you could actually hear the electricity running through the cars.
The Gibbs car was an adaptation of the experimental car. Aluminum was used in place of steel to reduce the weight of the car. The design specifications ensured that they would be stronger and more crashworthy than the composite car. Each side contained a heavy steel girder, and this gave the cars enough strength so the floor and other parts of the structure would be light in weight. Another innovation in car design came in 1916 with the introduction of the low-voltage subway cars. These would be the final fleet of IRT cars for many years. The multiple unit door control, MUDC, was introduced in these cars in the early 1920s. It required only one conductor to control all of the doors on a train, reducing the need for multiple conductors. In the early 1920s, the BRT went bankrupt and was reorganized as the BMT.
The BMT was a rather progressive outfit. They were always looking to improve service. So they decided to see if they could come up with something even better. And in the mid-1920s, they set out to design what they called an articulated car. And it was 3 bodies joined together permanently, and they only used 4 trucks. So in other words, 2 of the car bodies shared a single truck.
The IRT low voltage and BMT cars had similar propulsion systems. This changed in 1925 with the introduction of the D-types. Arguably the best of the older style BMT cars, they introduced articulation to New York subway cars. This principle allowed the 3-section units to be placed on 4 trucks instead of the usual 6. The Ds were heavy, extremely well built, and corrected a few deficiencies inherent in the standards. One D unit had 800 horsepower as compared to the equivalent 2 standards that had only 560 horsepower. The D-types were capable of greater speed and boasted a quieter ride. The Board of Transportation drew heavily from the IRT and BMT cars and developed a design that utilized the best features of each one. These cars would be used on yet another system, called the IND.
And then as they expanded the IND, they built more and more cars until they were all the way up to the R9. Everything from R1s through R9s were pretty much identical. They were interchangeable, they could be operated interchangeably among themselves. And that was the standard car for the whole 8th Avenue or independent subway system.
Finally, a car that was 60 feet long and 10 feet wide that used 1 motor and 1 trailer truck became the optimum choice. These dimensions are still used today for the new B division cars that serve the letter lines.
In the early 30s, with WPA assistance, Brooklyn Manhattan Transit, also known as the BMT, initiated the building of 2 multi-section articulated experimental cars using the most modern materials available. Pullman built the Green Hornets using aluminum, and Bud built the Little Zephyrs out of stainless steel. They were delivered in 1934.
The BMT was faced with the need to have a car capable of running on elevated structures, as well as entering the tunnel system. The older elevated lines could not withstand the weight of the B and D-type cars.
So in 1934, they came out with 2 experimental lightweight trains, and they were also articulated.
The Multis were the first cars to run on both the elevated structures and in the subway. They were the longest articulated units ever operated on the New York City transit system. Measuring 179 feet in length, they were also the lightest, weighing under 90 tons.
They were ahead of their time. They had dynamic brakes also, a different braking system. The cars were shorter, and they only had 2 doors on one side per car. It was unique in the sense that they had a special button in the doorpost that when the train was laid up at a terminal, when it was cold outside, they kept all the doors closed, and they would activate this circuit, and the passengers themselves would push the button open, and the doors would open. There would be a slight delay. They could come in, and then the doors would close.
1939 brought the World's Fair to New York City. But how do you move millions of people in and out of one borough? The IRT received permission to order a small fleet of 50 cars from the St. Louis Car Company and to add express service on the Flushing line. The cars were designed by the Board of Transportation and the IRT and went into service in 1939 to much fanfare from the riding public. The center track on the Flushing line would be decided upon for express service to and from the fair. The BMT rebuilt many of its 1200 and 1400 series elevated cars into Q and QX type units. Platforms were enclosed. Doors were inserted into the car bodies. And all cars received multiple unit door control.
But the World's Fair cars were all steel cars also. Steel exterior and also interior. Well, they had metal hand straps in them, and they did have rattan seats originally. And they were two-car units.
The Clark Equipment Company built the next generation car designed by the BMT. Known affectionately as Bluebirds, these compartment cars were the BMT's last effort to create lightweight cars for elevated subway service.
They had blue felt seats on the inside. They were very comfortable. They were modernistic, nice. They had signs that would change on the end over the storm door. They had what they call a Sinistron control equipment, where the motorman had only one handle for operating the train and applying the brakes. It was a modern type car. It's a nice looking car too.
Bullseye lighting fixtures and mirrors added an Art Deco touch to the interior of the cars. The heating system, ventilated panels, were housed beneath the seats. And the cooling system utilized forced air ventilation. On June 1, 1940, New York City purchased the property of the Brooklyn Manhattan Transit Corporation. On June 12, 1940, the Interborough Rapid Transit property would also be purchased. This unification resulted in perpetuating the lines known as the IRT, BMT, and IND, whose abbreviations are used to this day.
And in 1948, when the first of the new cars came in, which was the R10, it had rattan seats, but it had fluorescent lighting. The doors still operated on air, but the cars now had what they call dynamic brakes, where the cars would coast and they would use the motors as they were turning as generators to slow the train down and then use the air brakes to stop it.
1948 to 1949 also brought the R11s. There were 10 cars built by Budd for the proposed 2nd Avenue subway. They were BMT and IND cars.
An all stainless steel car. It was built in 1948. And it had heaters in the seats that were different. In other words, they used the dynamic brakes of the car as the train would slow down. When the motors became generators, the electricity that was generated by these motors was funneled to resistors. And the resistors were mounted in a box, and there was a blower in the box that would blow the heat underneath the seat to warm up the car.
In 1953, the New York City subway system was placed under the control of the New York City Transit Authority. The acquisition made the New York City subway eligible for state funding for certain projects. However, ownership of the physical plant and equipment would remain with the city. The 1950s also ushered in a new car called the R16. They were 60 feet long and 10 feet wide and were built by the American Car and Foundry Company. They went into service on January 11, 1955 on the Jamaica line.
The seating on the IRT cars remained longitudinal throughout the career, even all the new cars that have come through today.
The R17s, R21s, and R22s were the replacement cars for the IRT high-voltage cars that were still in service after half a century. These three similar classes of cars were built by the St. Louis Car Company.
Between the late 1940s and early 1950s, new IRT cars began to serve the Queens section of the IRT. The R17, R21, and R22 replaced the old high-voltage equipment, including the 1904 Gibbs car.
Recalling the old cars, and in my opinion, which were the best to operate, I would say they were the newer R-type cars, the SME cars. They were more reliable, and they were very responsive. The cars would accelerate nicely, and when you had to brake, you couldn't really make a smooth stop, and you would give the passengers a nice ride.
About 1960, we came in with an R22, which ran on the Grand Central as a Grand Central station as an ATO unit, automatic train operator, where at that time we had a train operator, or motorman as they called him in those days. He sat in a cab, and all he did was monitor the train. As a safety procedure, they put a train operator or motorman in the cab.
The R21 and R22 were almost identical to the R17, including performance. One of the most beloved trains by passengers was the Redbird. It was comprised of 5 distinct types of IRT cars that became famous for their longevity and presence on the IRT lines. The R26 and R28 classes were the last cars built by the American Car and Foundry Company for New York City, delivered between 1959 and 1961. Built by the St. Louis Car Company, the R29s featured a bright red exterior paint scheme with pleasant colors for the interiors. With picture windows and a powder blue and off-white paint scheme, the R33S was a small fleet of 40 single cars manufactured in the World's Fair car configuration. The R36s were attractive new cars for the 1964 World's Fair. They replaced the R12 and R14 on the Flushing line. On the BMT and IND lines, the Budd Company won the bid for the R32s. Their proposal was for all stainless steel cars, saving weight and reducing maintenance. The R32 class is still running after 40 years. The end of the 1960s brought about another change, not to the cars themselves, but to the agency that runs them. In 1968, the New York State Legislature created the Metropolitan Transportation Authority, which became the New York City Transit Authority's parent organization. In 1971, under the MTA, the New York City Transit Authority purchased the R44s. They were a radical departure from the previous subway cars. These BMT and IND cars were 75 feet in length. They were high-speed, high-tech cars, resembling a railroad commuter coach. The idea was that 8 cars could provide the same service as 10.
It was too much too soon. From a technical point of view, this design changed quite a bit on the R44. It was revolutionary instead of being evolutionary. These cars were capable of high speeds. They held the world record for a subway train of more than 87 miles an hour. They were longer trains, more similar to the commuter trains being used on the Long Island Railroad and Metro North. And they also had the different modes of operation, including automatic train operation.
By 1981, in order to prevent the collapse of the entire subway system, considered to be the economic lifeline of the city, MTA New York City Transit obtained $3.9 billion in order to purchase 1,775 new cars and the major overhaul of 4,177 cars during 2 capital program years, 1982 to 86 and 1987 to 91.
After the bad times of the 1970s and a period of rebuilding in the 1980s, the decision was made to overhaul the existing fleet. An effective maintenance program, known as Scheduled Maintenance System, or SMS, allowed the fleet to return to a state of good repair.
SMS is an acronym for Scheduled Maintenance System. This is a program that overhauls the primary components of the subway car. For example, the pneumatic components, the motors, the undercarriage, which consists of the truck's wheels and motors, the car body. All of these very important components that go into making the subway car operate efficiently are overhauled periodically.
The R62 and R62A changed very little from their predecessors, the R36s.
When it was time to buy the R62 cars, the MTA formed a steering committee to come up with a design for these new cars. At the time it was decided that based on the poor experience with the R44 and 46, we should go back to a more conventional design. And actually the technical specification for the R62 was that the R62 had to be compatible with the R36. Now the R36 were built and delivered in the early 60s. So it's like we took a step backwards, almost 20 years backwards in technology to make it simple and more reliable.
During the early 1990s, Kawasaki Railcar and Bombardier Transportation built both the R110A and R110B, which were referred to as the new technology trains. These were to be the next generation of new technology subway cars.
Based on our lesson learned from the R44 and 46, where we procure new cars without testing new technology first, MTA made a very wise decision that before we buy hundreds of new cars, which were coming up in the future years, we would test the technology first on 2 prototype trains.
A few of the revolutionary improvements are alternating current motors, passenger intercoms, and automatic station announcements. Beginning in October 2000 through May 2005, New York City Transit has accepted and placed into service a total of 1,842 rail cars referred to as New Millennium trains. The R142, R142A, R142S, and R143 cars are designed to improve safety and reliability. Passengers have more amenities, such as flip-up seats, improved interior layout, along with a smoother, safer ride.
For me, the biggest improvement has to be announcement quality. For years, we were always told that announcements were inaudible or we had defective public address systems. With the onboard announcements or the automated announcements, those complaints are very few and far between.
While it would take weeks to talk about the development of the subway cars, Gene Sansone has put it all together in a book entitled New York Subways, an illustrated history of New York City's transit cars. The book outlines passenger car development for every type of New York City rapid transit car from 1903 to the present day.
We felt we needed to bring it up to date and to include description and an historical and technical narrative about the new Millennium Trains fleet, the R142, 42A, the R143, R160, and that's what the Centennial Edition does. Basically, it brings the historical history of subway car engineering all the way up to present day.
660 rail cars will be built by Alstom Transportation and Kawasaki Railcar to replace the aging B Division fleet. Some of the newly purchased R160 cars were delivered by Kawasaki in July and August of 2005 and are undergoing various tests and inspections prior to being placed into service.
The design of the subway car is based on an evolution whereby we look at the design of previous car classes and learning lessons from what worked, what didn't work, we will specify the new car requirements. As long as we follow this process of evolution, we had a lot of success. So what we need at the MTA, we don't need revolution in design. We need step-by-step evolutionary process, which guarantees that our trains are modern, they have the latest technology, however, it's proven and it's reliable.
New York City's subway system, although not without its problems, is the lifeline for New Yorkers and visitors to the city, and a mode of transportation that other countries seek to emulate. From the first immigrants in the 1800s to contemporary residents today, New York City is still one of the most vibrant and exciting places to live and visit. And the subway cars are ready to take you to your destination in a New York minute.